All right, so you will see that for example one, I have example one, then I have example one continued. We're going to handle this problem in two parts. First of all, please do not freak out about the size or the number of words that we have to read in order to do this problem. Yeah, there's a lot here, but we're going to go through a process of making sense of it. And I need everyone to understand that as we set each of these up, we're going to be setting them up using the same principle that we did when we did problems like sum of the money plus sum of the money equals all the money. It's just that in this case, it's not always going to be money that we're talking about. For instance, in this first example, we were talking about CDF Appliances that has assembly plants in Atlanta and Fort Worth, where the company produces a variety of kitchen appliances, including 12-cup coffee makers and a cappuccino machine. So putting some meat on this really quick, everyone, I would read these a couple times and make sense of them before you start the problem. We need to understand that we have two different plants where these coffee machines and cappuccino machines are being made. At the Atlanta plant, 160 of the 12-cup models and 200 of the cappuccino machines can be assembled each hour. At the Fort Worth plant, 800 of the 12-cup models and 200 of the cappuccino machines can be assembled each hour. CDF Appliances expects that at least 64,000 of the 12-cup models and at least 40,000 of the cappuccino machines will need orders for that many of each. At each plant, we have restrictions about the number of machines that can be created, given the plant's capacity to fill the orders. We need to write a system of inequalities that describes these assembly plant constraints, graph the solution region to the system, and label the corners of the solution. So there's a mouthful there. Take a moment, read it a couple times. If you need to pause the video to do so, do that. I'm going to move on with setting up the system of inequalities. What is going to happen every single time that we do this, everyone, is that we are going to go through a series of steps. Our first step is going to be to find the totals. And that's going to be crucial for us setting up our inequalities. And so if I read back through that again, maybe take a moment to do that. Totals are usually going to be the biggest numbers in the whole darn thing. And I see that my totals are right here. I expect orders for at least 64,000 12-cup models and at least 40,000 cappuccino machines. So I'm going to begin by writing those numbers down over here on the right. Okay. Now I need to create a label that matches those numbers. And so CDF Appliances expects orders for at least 64,000 of the 12-cup models. And so I'm going to put a line here just to separate my two inequalities because I want to make sure that I don't get all slanted and out of whack. That is for the 12-cup models. And the 40,000 is going to be for the cappuccino machines. So somewhere between in this space here, we're going to come up with an inequality that represents how many 12-cup machines and cappuccino machines can be produced given the constraints. So what we need to do to begin with this is go back and begin reading and saying, okay, what other parts of this problem have 12-cup and cappuccino machines in them? And we need to come up with labels or titles for our columns. So we'll have a title here. We will have plus something. And we will have a separate title here. So again, this is exactly like sum of the money plus sum of the money equals all the money. We're always going to be adding. We just need to go through the problem and search for what those titles need to be. So let's read again. I'll just start at the Atlanta plant. 160 12-cup and 200 cappuccino can be assembled each hour. So my Atlanta is going to go there. I can make 160 12-cup models. And we need a variable here, so we're going to call Atlanta our X variable. And we need 200 cappuccino machines. We're still in Atlanta, so we are still going to use the X variable. If I continue reading, everyone, at the Fort Worth plant, so Fort Worth, we are able to produce 800 12-cup models and 200 cappuccino machines each hour. So Fort Worth is a different plant. We're going to use a different variable to represent it. We will use Y. And 200 cappuccino, we will use Y. Sum of the money plus sum of the money equals all the money. We are always going to be adding, and I have gone through everyone and highlighted the keywords for the inequality symbol on each of these problems for you. Orders will be at least, so that means we need more than or equal to the 64,000, and we need more than or equal to the 40,000. And so that's how we go about setting up our inequalities, everyone. You can see that for Fort Worth, that's my column, and for Atlanta, that's my column. And then to begin this whole darn thing, I find the totals and the labels. So again, number one is find the totals and the labels, do the green stuff first, and then we look for our columns and put them in place, the yellow and the blue. So I'm going to move the iPad off screen here, so if you need to write this down, please do that now. Pause the video, and I need to move to GeoGebra. So in GeoGebra, I've got a new graph here. I very simply just need to put in those two inequalities. 160x plus 800y is greater than or equal to 64,000. And you'll see I had you'll notice if you if you're just watching the video, you'll see that I had a blip of a graph show up here and then it disappeared. It's because it's way out in space somewhere. I'm going to have to zoom way out to find it. And there it is. And again, I'm trying to move my grid. I can't because I need to click that arrow. So there's my first graph. My next graph is 200x plus 200y is greater than or equal to 40,000. And so you can see my inequality here. I've got my darkest region up here. Again, I'm only looking in quadrant 1, and I'm considering the y-axis and the x-axis to be boundaries here. So I see a corner right there, I see a corner right there, and I see a corner right there. Those three corners represent the possible options for this company to produce these 12-cup models and cappuccino machines. Each of these options is going to cost a different amount and have a different amount of profit associated with it. And in the case of this one, the next problem, example 1 continued, is going to be talking about costs. And so we're going to be looking for these three options right here, get the job done. Which of these options keep the cost the lowest? And there's going to be a relatively large difference there. So our job again is going to be to find these 3 points, any corners that abut the dark purple region. So again, to do that, what we need to do, as I did in the in the Schlegel Need to Know notes, we can copy or duplicate these inequalities and then just change these symbols to an equal sign. You could also retype them by hand if you choose to. That's your business. Then everyone, and you'll notice I need to point out that Wolfram, I almost said that GeoGebra will take my input and then simplify it. Basically what they've done is GeoGebra recognizes that it could divide all these numbers by 160 and put an equivalent equation here. Pay no attention to that. Just make sure that whatever you put in matches what you meant to put in. Lastly, everyone, I do need a line on the y-axis and I do need a line on the x-axis. So I'm going to put in x equals 0 to get a line on the y-axis. And I'm going to put in y equals 0 to get a line on the x-axis. What that's done is the inequalities have created my shading. These two lines drew a line over this inequality, the line right there, and a line over here. X equals 0 and y equals 0, put a line on my x-axis and my y-axis. That makes it so that I can come up to this tool, get the intersect tool, and plot points at the places where these lines intersect. So our possible solutions to this system of inequalities, or the possible options for this company, are to either do, and again, it's important, I'll pull my iPad back up here and pull this to the side so we can kind of connect these ideas. Point A has a x value of 0 and a y value of 200. So when x is 0, that means the Atlanta plant is shut down. It's not doing anything. 200 on the y value means that the Fort Worth plant would be run for 200 hours to get the job done. B, 150 and 50 means that another option is to run the Atlanta plant for 150 hours and Fort Worth plant for 50 hours. And C, the option is to run the Atlanta plant for 400 hours and the Fort Worth plant for 0 hours. Now, a lot of people will say, well, why would I shut the Atlanta plant down, or why would I shut the Fort Worth plant down? Why don't I run them both? And why aren't these numbers here the same, like 100 and 100? The answer is because we had to take into consideration constraints that prevent us from being able to do whatever we want. And as we read in the problem, it is the case that these two different plants are limited in the amount of machines that they are capable of producing. Setting this system up and finding these points is a way to figure out the 3 most efficient ways of operating these plants. And then what we're going to end up doing in the next part, which is example 1 continued, we're going to use these points to figure out which of these options is the cheapest for this company. So again, I'm going to take these points and label that and bring them over to my iPad here. I've got 0, 200. And again, that's the Atlanta plant running for 0 hours and the Fort Worth plant running for 200 hours. I've got 150, 50, which is the Atlanta plant running for 150 hours and the Fort Worth plant running for 0 hours. And I have 400, 0, which is C, which is the Atlanta plant running for 400 hours and the Fort Worth plant running for 0 hours. With that, everyone, I will see you back here in just a moment for example 1 continued.